Okay, so this video starts on page 7 of your Unit 5 Part 4 packet, and we're going to review again some of the vocabulary for functions, and then we're going to learn how to represent a function as a graph. So you know that your input is your x and your output is your y. And other terms, when we think about the x coordinate besides input, is domain, because the set of all x values is your domain. Your x coordinate is your independent variable, and it goes on the horizontal axis. Your y coordinate is associated with the output value, the range. It's your dependent variable, and it goes on the vertical axis. Okay, so here, let's look at this input-output table. And you can look at this input-output table, and you could rewrite that as a set of ordered pairs. And once you rewrite it as a set of ordered pairs, you can then graph it on the coordinate plane. So when we graph a point, like for example, we're graphing the point 1, 2. We know the x values first, the y values second. I start at the origin. I go over 1 up 2. So this is the point 1, 2. And I should erase this. Okay. Then for 2, 3, I go over 2. So over 2, up 3, put a point there. For 3, 4, I go over 3, up 4, put a point there. And for 4, 5, I go over 4, up 5, and put a point there. Now I'm going to erase all this. And some of you may think, oh, I have a nice little line there. I should connect the dots. But you shouldn't. And the reason you shouldn't connect the dots is because it just said graph these 4 ordered pairs on a coordinate plane. So you only have 1, 2, 3, 4 ordered pairs. If I connected these and put a line through it with arrows, I would be insinuating there were an infinite number of ordered pairs that I was graphing, when in fact I'm only graphing 4. Okay. Now here, this says graph this function with this domain. So to do that, I do 0, 2, 4, 6, 8, and I plug in to get my y values. Now it wants me to graph these 5 points on this coordinate plane. And again, if I'm only graphing 5 points, should I connect it at a line? And the answer is no, not if they're specifically telling me this is my domain. So 0, 0, I go 2 to the right, up 1. Then I go 4 to the right, up 2. 6 to the right, up 3. 8 to the right, up 4. And that's my graph. Okay, so we are graphing our function. So you can represent a function many different ways. You can represent it as a set of ordered pairs. You can represent it with mapping. You can now represent it as graphing, or we could represent it as a table. So now this says, here is a graph. I want you to go, instead of going from a table to a graph, let's go from a graph to a table and find the rule. Okay, so we're going to make a table for this graph, and I'm going to look at this point first. That point is 2, 0. I'm going to look at this point. That point is 4, 1. This is 6, 2. This is 8, 3. And this is 10, 4. So now I'm going to come up with a rule for my table. And one of the ways so make sure I'm right. Okay. So to come up with this rule, I'm going to say I'm going up by 1, up by 1, up by 1. This is going up by 2, up by 2, up by 2. And so my rule might be y equals 1/2 x, and then I have to subtract 1. So find a rule, and let's see if my rule works. Well, half of 2 is 1 minus 1 is 0. Half of 4 is 2 minus 1 is 1. Half of 6 is 3 minus 1 is 2. Half of 8 is 4 minus 1 is 3. And so that does work for my rule. So this says write a rule that describes the relationship, and the rule is 1/2 x minus 1. And then it says, once I know the rule is 1/2 x minus 1, describe the domain. Well, my domain is 2, 4, 6, 8, 10, and my range is 0, 1, 2, 3, 4. Okay. So here you're going to do this on your own. They want you to graph that function with that domain. And again, because they're only giving you 1, 2, 3, 4, 5 points in the domain, you're only going to have 5 dots on your graph. You're not going to connect the line. So this is x, this is y. I'm putting in 0, 3, 6, 9, 12. This is a 1, this is a 2, this is a 3, 4, 5. So I do 0, 1, 3, 3, 2, 6, 3, 9, 4, and 12, 5. Okay. Now, for here, I'm going to go from looking at points on a graph to making a table to finding a rule. So you try to do this on your own. Turn this back on and see if you're right. So here, my first point is 1, 0. My next point is 2, 3. And it's 3, 6. And 4, 9. So my y's are going up by 3. So my multiplier, and this is going up by 1, so my multiplier is 3 over 1. So y equals 3x. And then I have to subtract 3, because y equals 3 times 1 is 3, minus 3 is 0. 3 times 2 is 6, minus 3 is 3. 3 times 3 is 9, minus 3 is 6. 3 times 4 is 12, minus 9 is 4. So this is my rule. And for the next one, I have 2, 6, 4, 7, 6, 8, and 8, 9. So this is going up by 1, while this is going up by 2. So my multiplier is the change in y over the change in x. So y equals 1/2 x. Well, half of 2 is 1, plus 5 is 6. Half of 4 is 2, plus 5 is 7. Half of 6 is 3, plus 5 is 8. So this is my rule. Okay. So now on this next page, this just goes over again. When is a relation a function? So in this first example, we see mapping. We know this is not a function. One way is there's 2 arrows coming out of the 2, not a function. And if we look at the set of ordered pairs, the 2's repeat, not a function. Here, there's only 1 arrow coming out of everything, so it is a function. But now we're going to look and see when these things are graphed, how do we know if it's a function or not? And we do what's called the vertical line test. The vertical line test says, if at any point you can draw a vertical line and it crosses the graph more than once, it's not a function. So you can see at the first example, that's a function. I like to think of it as like an operation game, and every time I cross the graph, it beeps. So here you see beep, 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 beep. These are both functions because every time I drew a vertical line, it only beeped once. Now, see what happens here when I draw a vertical line. Beep, 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 beep. That means it's not a function because when I drew a vertical line, I passed through the graph more than once. Here, this not a function because beep, beep, I pass, even if it's only, that's the only place, it's not a function if there's ever a place where you can draw a vertical line and pass through that graph twice. So that is what's called the vertical line test. And if you can draw a vertical line and pass through the graph more than once, then that is not a function. Okay, so this next part is going to be your homework. I just do want to point out that when you do your homework here, we are setting up tables. So when you do the homework, I expect to see everyone to have tables when they do this, okay? They give you a domain and a rule, and I want you to show me that you plugged in the domain and the rule and give me a table, okay? And then on this next page, you're going to have to do the tables again to find the rules. So again, I do expect to see tables drawn for the homework, and the answers are included.